Hello, everybody, ladies, gentlemen, and non-binary. Happy National Coffee Day. As you know, I'm rather fond of my coffee. I'm Amelia Thompson, your very caffeinated webinar host, back once again for one of our final webinars of 2021. Actually, we only have 4 left after today's presentation. Joining me is Dominic Cook. He is a product manager for our optoelectronics division at Wurth Elektronik in Germany. Today we are going to be discussing disinfection using UV LEDs. Very popular topic, especially with what's going on within the last year and a half. Now, if you have any questions during today's webinar, make sure you are asking them in the questions box. I do see a couple people commenting in the questions box. Feel free to throw comments out there. You can communicate in that way. Tell me how you like your coffee on this National Coffee Day. I like mine black, much like my soul, but you can go ahead and test out the chat box. We do have a few people coming in. Looks like Charles from North Carolina is back. Welcome back, Charles. And we have a Sven. Sven, where are you from? Might have to give him a minute to respond, but welcome to today's Wurth Elektronik webinar. Now, for those of you who have not joined us today, as a reminder, because you registered for today's webinar, you will automatically receive the video on demand as well as the recorded video on demand and a PDF of the slides when they become available within the next 24 to 48 hours. Simply look for the follow-up email from here for you at we-online.com. And if you have any questions that don't get answered at the end of today's webinar, you can reply back to that email. Again, here for you at we-online.com. We are kicking off October. Make sure you register for our next webinar on the 7th. That's a Thursday. It's RF behavior for pin and socket headers. And again, October 7th, register online at www.we-online.com/webinars. And of course, all of our webinars are possible thanks to our exclusive sponsor, Digikey Electronics. You can find Wurth Elektronik components online at digikey.com. Now I'm going to hand it over to Dominic Cook as he proudly presents Wurth Elektronik's presentation, UV LEDs for disinfection.
So, hello from my side as well. So I'm Dominic Kirk. I will be presenting the webinar today. So as mentioned already by Amelia, it's about disinfection using UV light and especially UVC LEDs. So yeah, I'm happy that you all joined, and let's dive right into it. So what is going to be happening this webinar? So first of all, I will explain a little bit on what UV light actually is, the difference between UVA, UVB, and UVC. Then I will explain a little bit on how disinfection works with the UVC light. Then, like for example, how the working mechanism is. You see already on the right-hand side, it destroys the DNA, but we will look a little bit closer how this actually works. Then also the wavelength dependence of the disinfection efficiency. And also what's really important for designers is I will give you some hints on what doses are required for disinfection. So basically the amount of UV light that is needed for disinfection. Then I will also show a few application examples and simulations. And in the very end, I will show a little bit something about safety and the maximum allowed daily doses to get on the eyes or skin. Because as you see on the right-hand side, the UVC light can damage DNA. So basically, it's also dangerous for us humans. So let's start with the with an explanation what UV light is. So if you look at the electromagnetic spectrum, you see there's a visible light spectrum from something like 400 nanometers to 780 nanometers. For higher wavelengths, the light is called infrared light, and for lower wavelengths, it's called UV light. And the UV light is now like separated into UVA, UVB, and UVC. So you see UVA has a wavelength from 315 to 400 nanometer, and it has less energy than, for example, UVB or UVC light. And due to this high energy of the UVC light, it's also so powerful for disinfection. So first I want to give you a short overview what our current Wurth Elektronik UV LED products look like. So currently in our portfolio, we have a few UVA LEDs with different wavelengths from 365 nanometer to 405 nanometers. And but also since a few months already, we have UVC LEDs with 275 nanometers and two different optical powers. So the optical power for the LEDs is usually called the radiant flux. So UVA LEDs usually are used in horticulture for security and counterfeit detection, but mostly in curing application, for example, for adhesives and glues. Whereas UVB are mainly used also for horticulture, but they can also be used for skin treatment or treating vitamin D deficiency. So this is a quite interesting application because actually you can combine those two, the horticulture and this vitamin D topic. So if you take some mushrooms and like during the growth process, you shine some UVB light on it, you will get those mushrooms will get loaded with vitamin D, and then you get like vitamin D loaded mushrooms, which is really interesting application for countries where you have a little bit or not enough sun to produce your own vitamin D in the sunlight. And of course UVC, which is mainly used for disinfection, but there are also a few sensing applications for that. But we will focus mainly on this disinfection. So you can, of course, do surface disinfection of masks, phones, whatever. And this can also be used in the food industry. So imagine you have eggs and you want to kill off all the salmonella on the eggs. Well, salmonella can cause food poisoning, so it's good to remove them before that. And you could do this with UVC LEDs. The other hot topic right now is air purification. Of course, you can use air filters, which also include UVC LEDs, which will kill off coronaviruses that are flowing in the air. But you can also use it for water disinfection. So let's have a little bit closer look how the disinfection actually works. So when a UV photon hits on DNA, it splits the chemical bonds of the nucleic acids. And in the end, it will result in a formation of thymine dimers, as seen here on the right. And this damage actually leads to the inactivation of this organism. If it's a bacterium, then the bacterium can't replicate anymore after those damages. Well, viruses don't have DNA, they have RNA, but there's a similar process happening for RNA in viruses as well. So now the question is, what wavelength is actually the best for disinfection? So there have been quite a few studies, and I'm showing just one of them. Here you see the black curve, which gives you the wavelength-dependent RNA damage. So of course, if you have more RNA damage, then the disinfection result is better. So, and what you will see is that for this RNA, for this specific virus, the peak is around 260 nanometers. So depending on what study you look at, this peak might shift by like 10 nanometers to either sides. And it also is a little bit different for bacteria. It will also be a little bit higher, I think, about 265. And but anyways, mostly the peak is somewhere around 260 and 265 nanometers. And compared to this, I show you here in red the spectrum of our new UVC LED. So it has a peak wavelength of 275 nanometers. And you see, it's not ideal. It would be, of course, better if the peak wavelength is close to those 260 nanometers. But it's not that simple, because what you also have to consider is not only the correct wavelength, but also you have to have enough light coming out of the LED. So basically, it doesn't help you if you have the right wavelength if your wall plug efficiency of the LED is way too low. And this is why I show you an overview of a few LEDs that are available on the market. And what you will typically see is that the wall plug efficiency for wavelengths below 260 nanometers or below 275 nanometers are considerably lower than for 270 nanometers. And so this is because of this, because this technology of 275 nanometers actually much more mature, the power that is getting out of the LED is actually much better than for lower wavelengths. So what I did here in the gray curve is basically just the product of the wall plug efficiency and the relative RNA damage. And this combined sterilization efficiency is in the end what matters for disinfection. So you will see this gray curve actually peaks around 275 nanometers. So this is why those currently the 275 nanometer LED is still the best technology for disinfection. So when a designer wants to have an application to disinfect something, it usually can be broken down to the question, I have a surface here and I want to disinfect it, and I have some LEDs, and the question is, how many LEDs do I need? How long do I need to turn the LEDs on? What is the distance of the LED to the surface? And to answer all of those questions, I want to give you a short introduction what can be done here. So what we offer as a solution is as additional information on our LEDs are those called wave files. So those wave files are measured data from our LEDs, which give the three-dimensional radiation, where the rays go in the 3 dimensions. So you can use this data in optical simulation software, which is shown here, to simulate something called the irradiance on a surface, on a detector. And this was done here in this example. And what you see here is for our LEDs, it looks something like this. So what you have is the irradiance, which is measured in watts per square meter. And you see it depends on where on the surface you are. So in the middle, you get a little bit more of irradiation than at the edges. So how do we get from here to an actually usable value, or to a point where we can say how much disinfection we have? So this is what I want to show you here. What you can do when you multiply the irradiance, which is the watt per square meter, which is like the power per square meter, and you multiply this with the time of exposure, then you will get the radiant exposure, or dose. This dose is the units of this dose are joules per square meter. So it's an energy per square meter. And this value is actually the one that is important for disinfection. So to kill some certain germ, you need a certain amount, a certain dose, so a certain amount of joules per square meter. And so there are different or there's a naming for different doses, stating how much of the germs you've inactivated. So if you have the D90 dose, then this means that 90% of the germs are inactivated. And D99, then you have 99% inactivated, and so on. So typically, to get from one D90 value to the D99 value to the next value, you always have to multiply this value by, so from here to here, it's like the factor of 2, factor of 3, factor of 4. And let's have an example. So if you have, for example, a D90 dose of 18 joules per square meter, this means that if you get a dose of 18 joules per square meter, which is here in the red area, then you have, in this red area, you have like 90% of your germs inactivated. So this D90 dose is very much different for different germs and different viruses and bacteria and fungi. And the tricky thing here is it's also very different for the same type of germ. So it very much depends on which research group is looking at it and how the protocol was to measure it. So there can be huge deviations from research group to research group in the results of the D90 dose. So you see, for example, here for the coronavirus, there you can find studies where you have values of the D90 dose starting from 6 joules per square meter up to more than 100,000. So there's basically a huge gap between them. But to get a usable value here for this presentation, I will use this 37 which is a median of those of a lot of studies here. So most of the studies to get this D90 dose were performed using so-called low pressure mercury lamps. So those are like UVC tubes that have been around already a few decades. And they are currently being more and more replaced by UVC LEDs because the UVC LEDs don't have this toxic mercury in it. And so the UVC LEDs are much more interesting for consumer applications here. So because most of the data are done with those low pressure lamps, it's also interesting to see what the relation is between low pressure lamps and LEDs if the D90 dose is similar. So we could look back to the wavelength dependence curve where we have a similar RNA damage for the 254 nanometers, which is emitted by the low pressure lamps, as for the 275 nanometers. But we can also look at this the study which showed that actually the dose required for the LED for 275 nanometer LEDs is almost exactly the same as the one used for the low pressure lamp. So those values can be used approximately in the same way because the efficiency is almost the same. So there's also a recommendation from the IES Photobiology Committee, which says for surface disinfection, you should get like 200 to 1,000 joules per square meter. And with those values, you see you can kill off almost everything here. So I want to show you a quick simulation, what I've done here, just for a UV panel consisting of 9 of our UVC LEDs. And just to give you understanding how these irradiation patterns and how those irradiation patterns can look like, and how fast it is to achieve a certain type of disinfection or a certain dose. So it very much depends on the distance. So you see, for example, here at the distance of 4 centimeters, you have a rather small irradiated area, but a large irradiance. If you increase the distance, you get a larger area irradiated, but also the maximum irradiance is much lower. So if you would be, if you want to get like the D90 dose for corona, so kill off 90% of the coronaviruses, we would now need to achieve the dose of 37 joule per square meter. And this can be done at 4 centimeters distance in 0.1 minutes, but at 20 centimeters distance, we already need like 1 minute. And okay, and on the other hand, for the dose of 1,000 joules per square meter, I just see that I missed a 0 here. It should be 1,000, not 100 here. Yeah, there so the time is much larger. So it depends on what kind of dose you want to achieve. So this 1,000 I wanted to put here is basically the maximum value here from this IES photobiology committee. So here in this case, it would be like 3 minutes or 27 minutes to achieve this doses. And what you see in this little inset down here is just a quick, like the how the disinfection times will vary with the distance. So basically, there's approximately a squared dependence. So if the distance is like doubled, then the time is like 4 times larger. So another important topic about when working with UVC light is safety. So generally, all UV light is dangerous, but especially UVC is dangerous because, as you've learned already, is that it can damage the DNA, which can lead to problems in your skin or also in your eyes. So this is why when working with UVC light, you should always wear protective equipment if there's light coming out of your application. And in applications, you should always take appropriate measures so that no light can go out. So there's also a value for the maximum allowed doses that you can get per 8 hours workday for 275 nanometers, which is 30 joules per square meter. So to give you a feeling how fast you can actually get this, let's look back at our example of this UV panel. If you have a distance of 20 centimeters, you can get this maximum doses in only 50 seconds. If you go to 4 centimeters, you can get this maximum dose already in 6 seconds. And if you go even closer to the LEDs, then you will already get this maximum dose in below 1 second. So you can get damage on your skin quite quickly with those LEDs. So this is why it's important to be careful when working with those. So let's give a short summary of what we've discussed so far. So basically, 275 nanometer LEDs can be used for disinfection, and they are currently one of the best technologies to do this. Then I showed you a few D90 doses for germ inactivation, and I showed that those doses can vary a lot, which needs to be taken into consideration depending on what kind of surface you have. You might need a longer a higher dose to achieve disinfection. And then I also showed you that we can use actually array files and optical simulations to simulate the irradiance and then to calculate a dose, an expected exposure time needed to achieve a certain dose and therefore a certain amount of disinfection. And then I showed you that the UV light is dangerous and you need to be careful when working with those. Now I want to show you real quick where you can find on our homepage those WAV files. If you just go to the product pages, you can see under downloads, you can simply download all of those WAV files together with many other data to our products. And I can also recommend reading our application note on UVC disinfection. The topics are similar to the ones given here in the webinar, but also described in more detail. So like if you want to learn more about this topic, I can forward you to this application note, and I would encourage you to read this. Here is a few of my literature. There's a lot of studies going on in the section of UVC disinfection, so quite a lot changing here. And yeah, that's it from my side. So now I'm more than happy to answer any of your questions.
And if you do have any questions, please feel free to ask them in the questions box. Our first question is, can optics like lens be used to bundle or spread UVC light?
Yes. So you have to be careful when using optics, because most common optics will not transmit UVC light sufficiently. So there are special optics like quartz lenses, which are like a highly purified quartz class, which actually have a good transmission for UVC light. And there are possibilities to get optics like lenses with quartz class, yes.
Thank you very much. And our next couple questions by different people are actually the same question. What is the expected lifetime for the LEDs? Does the intensity degrade over the operating lifetime?
Yeah, definitely. Because this is still a new technology, and there's still a lot of development ongoing here. So basically, in the future, it should increase, but currently it's something around 3,000 hours for our LEDs when you drive them at typical currents and you keep them at room temperature. So of course, you have to be careful that they don't heat up too much, because heating up will definitely reduce the lifetime. So when using them in application, you have to be careful that you get enough heat dissipation away from the LEDs.
Excellent. Our next question here. Is there an effect on disinfection if I use a switched power source?
So if it's like a PWM signal, I think, so basically on, off, I think this is what the question is. So in the end, what matters is the doses that has been acquired on the surface. So imagine you have like once 10 microseconds on and then 90 microseconds off. Then what you would need to do is take an average value, or basically the integral value over the whole time that it's exposed. So basically, in this case, it would be like the total exposure time divided by 10 if you have like only 10% on time.
All right, we have a few more questions coming in. Again, if we don't get to your question or if we run out of time, maybe if you think of one a little bit later, feel free to reply to our follow-up email at hereforyou@we-online.com. Our next question, what is the wall plug efficiency?
Something around 3%. This UVC LEDs, they are quite new technology. So a couple of years ago, it was much lower, and but due to the coronavirus, mainly this boosted the technology for UVC, And since the start of the coronavirus, actually, you saw already a lot of increase in the wall plug efficiency. And currently it's something like 3%, but it will definitely go up in the future. But it might take a few years to reach values for similar to other LEDs.
Excellent. Now you discussed compatibility of UVC with humans. What are the material compatibilities? What are those issues to be aware of when using UVC? Do some materials degrade when exposed to UVC?
Yes, definitely. So most polymers will degrade with UVC light. So what you will see, for example, if you have a 1,000 disinfection cycles for this like 37 joules per square meter, and you would disinfect 1,000 times, you would see, for example, a little brownish discoloring for most polymers already. So yes, there's definitely this effect of like changing of the color, and some polymers will also like the material, the strength will reduce itself a little bit. So it needs to be considered when you are working with UVC light and you have surfaces that are exposed to a lot of UVC light. You definitely need to consider taking polymers that are UV resistant or some metals. So there are polymers that are UVC resistant, which are like fluorinated or chlorinated polymers like PVC or Teflon, which are like those, there the chemical bonds are so strong that the UVC light can't damage them. And so those are a possibility, but there are also like UV absorbers, similar to what you have in like sunscreen, that you can add into different polymers, which then makes them more stable for a long time UVC irradiation.
Excellent. A couple more questions here. How would you suggest to measure the light emitted from a prototype UV lamp?
Well, it depends what you want to learn from measuring your lamp. So if you want, if you're interested in the disinfection result, then you have your you have your application, you have your lamp. It has a certain distance to your surface, and then like one possibility to check the the optical behavior of the LED is to have a UVC detector and measure the irradiance for this lamp at different positions on the surface. And then you get an irradiance map similar to those that I showed earlier. So basically, something like this you can also like measure if you have a UVC detector. You can measure this on the surface. If you want to have a study performed, like a real proof from a laboratory that it does disinfection, this lamp, then what you can, so there are some labs that can do this. And basically what they will do is put some bacteria under your lamp and then test how much of the bacteria are still alive afterwards. So those are the two possibilities to test the UV lamp prototype.
And our final question here, and again, we do have more questions coming in, but we will answer those after the webinar. Finally, do you make a sensor to measure the dose from UVC LEDs?
Currently, we don't have a sensor for this. We're definitely looking into this. But it is definitely interesting in applications to use UVC sensor as well together as with the UVC LEDs. Because definitely what you can do when you have a sensor, you can monitor also like the degradation of the light output over time. So then you can see, for example, at what time you need to change the lamps. And actually there's a German water disinfection norm where they actually state this as a requirement for like drinking water disinfection with UVC light. So basically there you have the UVC source, and then you have a detector checking if there's still enough UVC light coming through the water. And something similar like this could be done also for other UVC application if it's required, if it's really a critical application.
Absolutely fascinating topic, fascinating presentation. Dominic, thank you so much for presenting our webinar today.
Sure, thank you for listening.
And that will do it for today's Wurth Elektronik webinar. Again, if we didn't get to your question, if you think of them a little bit later, we will be answering these questions that have been rolling in, but feel free to reply to our email where you will receive the video on demand and a PDF of the slides from here for you at we-online.com. And if you want to stay up to date on our webinars, you can always follow me on LinkedIn. You can also follow our Wurth Elektroniks page on LinkedIn. My name is Amelia Thompson, and don't forget about our new Wurth Elektronik What's Up radio podcast, where each week I'm bringing application notes, blogs, press releases, and our webinars to an audio format. This week's episode is multi-layer chip antenna placement and matching, and it goes live tomorrow at 12 p.m. Central. You can listen to the What's Up radio podcast on Spotify, iTunes, Google Podcasts, basically anywhere where you would want to download a podcast. Again, that's Wurth Elektronik's What's Up radio podcast. I will hopefully see you next Thursday with RF behavior for pin and socket headers. That webinar, register online at www.we-online.com/webinars. I'll see you soon.